Welcome back to Namaste Node.js. In this video, we are going to talk about thread pool. Inside libuv, we already saw in the last video about event loop, about callback queue, how event loop works. What are the different phases of event loop? We saw a lot of internal concepts that how actually callbacks are scheduled in the callback queue, and then those callbacks are picked by event loop, and then JavaScript engine executes those callbacks. We saw all that functionality, isn't it? We were talking a lot about event loop and callback queue in the previous episode. In this episode, we are going to talk about thread pool. Why does libuv needs a thread pool? And we will also answer the most famous interview question, which is Node.js single threaded or multi-threaded? Right? So that's a very famous question. We will answer this today in this episode. Okay? Before I talk about thread pool, okay, first of all, there are few things which were left to discuss inside event loop. Let me finish them first. There are few topics just which were left in the last video. Now in this episode, I am going to cover a little bit of event loop, then we'll move on to thread pool. Okay. So in the last video, I already told you about these phases of the phases of event loop. We saw that, okay, there is process.next take and promise callback, and this cycle happens before every phase, right? Before starting the every phase, these process.next take and promise callbacks are checked, and all these things we studied, isn't it? Now, what we will do is, now, in the last video, I told you that there are 4 phases, right? I told you there are 4 phases. But let me tell you that when you will actually see the event loop on the official documentation, there are more than 4 phases, right? There are more than 4 phases. These are the 4 phases I showed you so that your understanding becomes easier. Understanding of event loop becomes easier. So these are the main 4 phases. There are a little more phases, right? So the best way to learn is to go to the documentation. So if you'll go to the Node.js official website, and if you will go and read about the Node.js event loop, you will just see the diagram. Okay. So I already told you about timers, right? There is a timer phase. I told you about poll phase. I told you about check phase, and I told you about the close phase. But there are 2 more phases in between, as stated by the official Node.js document, right? These are pending callback and ideal and prepare. Okay, so what are these 2 phases? And if you will see, these phases occur in a sequence: timer, then pending callback, then idle and prepare, then poll, then check, then close callback, and then this loop goes once again to the timers. Got it? And we already know that incoming connections, data, etc. come via poll phase. Right? We have seen all this, right? We have already seen all this. Let me just zoom a little so that it is much more visible. So we have seen all this. We have not seen this pending callback phase and idle prepare phase. So what is pending callback phase and idle prepare phase? Let me tell you. Suppose if there are some callbacks, okay, so let us just read over here, right? It will make more sense. Executes IO callbacks which are deferred to the next loop iteration. So whenever there are IO callbacks, right? So IO callbacks are handled by poll. So suppose over there, for any reason, these IO callbacks can be deferred to the next event loop cycle. So suppose if there is some error, right? Suppose you want to retry something, right? Or if any reason, there can be multiple reasons why we want to defer the execution of these IO callbacks, right? Sometimes the case could be starvation, right? What happens is you cannot starve the queue. All these, we feel that, okay, the logic which I told you is a very easy logic. No, it has lot more complexity. There is a way that these queue can starve, right? Suppose, see, a lot of recursive call started happening inside this poll queue, right? So, but there is a limit, right? Otherwise the other queues will starve. So what happens to reduce starvation? There are a lot of, sometimes we defer these callbacks also. Okay. Sometimes we defer these callback to the next queue, right? Next cycle of the queue. So in that case, there is a phase which is known as pending callbacks. So suppose if there are some pending callbacks, so it can happen in the next cycle. So suppose if there are some IO callbacks which are pending, which will not executed in the poll phase, they can be executed in this pending callback phase. That is where this phase is. This is not a very important phase. That is why I did not make it over here. But after the close phase, sorry, not after the close phase, after the timer phase, that phase comes over here, right? Somewhere over here is the pending callback phase, right? Basically, if there are some IO callbacks which needs to be handled in poll phase, but it did not handle, so it can be handled in the next tick. What is a tick? One tick of the event loop is known as, one cycle of the event loop is known as tick. Okay, so note down this thing, tick. One full cycle, one cycle is known as tick of event loop, TICK. Okay, TICK, it is known as one tick. Got it? So now if you will read the documentation, right, it will make sense, right? Now it will make sense. Executes IO callback deferred to the next loop iteration. Okay, so whatever callbacks are deferred to the next loop iteration, that will happen in the other phase. Okay, in the next tick, sorry, next loop iteration. Now there is one more phase, idle and prepare phase. Now this phase, if you will read, it is used only internally. So basically we as developers don't need to take care of anything. There are some idle prepare checks which which basically Node.js or libuv library is doing while it is running the event loop. So these are idle prepare checks. So but we as developer don't need to take care of it, right? So that is why it's not that important for us. The most important phase in the event loop is the poll phase, which we should be worrying about, which we should be concerned about. Okay, so why I am showing you all this is, so suppose if you will go to Node official documentation, go read everything about event loop, right? I would encourage my students, I would encourage all of you who are watching these videos to go to this website, read about event loop, right? When I have explained you all these concepts, right? When I have explained you all these concepts, these things will make so much sense to you. If you would have read this earlier, it would have been very complex for you. You won't understand by reading just this documentation. It is very complex, right? It also took me a tough time to read and understand all of it. But once I have explained you the logic, once I have explained you this diagram, now it will make sense. Now everything will make sense over here. Okay, so please read this. I would want you to read this up. Now, one more thing I wanted to tell you is that if you will go to libuv, right, you will see another diagram of event loop. Okay, now you will say, Akshay, you showed us this diagram. Now you are saying that, okay, Node's official diagram is this. Now if you will go to libuv, right, this is the libuv official website. And over here, if you will go and see the IO loop, right, this is the event loop, right? This is the IO loop, this is the event loop. Okay, IO or event loop is the central part of libuv, right? And if you will see this diagram, this is much more complex than what it is there, right? But at the end of the day, whatever I told you, just remember this and your life will be sorted. Okay, just remember what I told you. It works like this, and before every cycle it just goes over here, right? So this is what I wanted to say. If you will go over here, you will mess up your head, right? But I would request you all to go to these, right? Once you have understood this diagram when I showed you, now go to this and read it up, right? Your understanding will become very strong, right? And if you will go to libuv documentation and read it, then your understanding will become even one more level deep. See, if you will read from the Node.js documentation, you will understand the event loop. But actual implementation of event loop is done by whom? The actual implementation of event loop inside the Node.js is done by libuv library. So libuv library, this diagram is the most accurate and fundamental representation of event loop. But this diagram has a lot of extra things, right? This diagram has a lot of extra things, and it is kind of like a dummy code, right? So that is why this diagram looks like this. So just read about it. You will understand what is happening over here, and this will make your understanding even more clear. Right? Earlier, when I was preparing for this episode, right, when I was preparing for the event loop episode, I thought that, okay, let me explain this diagram. But, I felt as a teacher that it will be very, very, very complex if I start explaining all of this. Right? It will be very, very, very complex. So that is why I did not touch this diagram. I made my own diagram, right? And this diagram works the best, right? It will make your understanding very clear. So remember this diagram and then just go through these theory, right? Everything will make sense to you. Right? Now if you will see, it is doing one and the same thing, right? Basically, it is initializing the loop time. Now, if I have to explain all of this, if I start explaining, it will take 1 more hour. But I am just quickly going through this. So basically, see, it basically initializes the loop, right? And then it runs the timers, and now it just keeps checking in, right? That whether the loop is alive or not, right? Then it will call the pending callbacks, right? Now you know the pending callbacks, right? In this phase, it will call all the pending callbacks which were pending from the last iteration of the cycle, right? Suppose in the last iteration, if there was something pending, so it will go over here and execute them. Then it checks, then it run the idle handles, then it run the prepare handles. So basically these two are the internal phases, right? You don't have to worry much about it, right? It is basically like event loop is preparing to run the IO. So it does some checks, it does some calculations, right? And then it starts the poll phase. So basically, I told you, right? Poll phase is a very complex phase, right? Poll phase handles most of the events, right? So that is why IO events. So that is why there is some calculations, there is some checks which event loop does before entering into the poll phase. So basically this run idle handles, run prepare handles, you can assume that it is preparing for the poll phase, right? Then it goes to the actual poll phase, it runs all of them, right? Then after running the poll phase, it again checks the handle, right? Run check handles. So check handles over here, it runs any set immediate if it is there, right? This is the check phase which is running the set immediate. After set immediate, what happens? This is the close phase where you close. Suppose if you have some callbacks associated to closing the sockets or something like that, so it handles over here. Now it updates the loop time and it runs the due timers and then it goes on again, right? So this is how this loop works. So if you will see clearly, this is also doing the same thing which I explained you over here, right? So I would request you to go ahead and read this up, right? Read this. And try to understand it. This is one more level deep and it will just help you, right? And just be curious, right? Why not? I had curiosity. I went and read a lot of things. It is very interesting. I told you, right? I let me give you a homework, okay? So in the diagram, I showed you that, okay, event loop waits. Right? Event loop waits at the poll phase. I told you, right? Event loop goes on. But when it is idle, then it will wait on the poll phase. This is what I told you in the last video. Can you tell me, this is your homework, find out that how do you identify that event loop waits, right? Where in the code it is written that event loop will wait? Where in the code it is written? Okay, first of all, let me show you the code, right? So let me just dive deep. This is what, sometimes me as a teacher, I get very confused that how much should I tell you? Because if you will go one level deep, there is so much thing inside working that it will be very complex for me to understand. So I keep a balance that I go deep, you should have in-depth knowledge, but then it should not be so complex that you don't understand, right? I want to make the deeper level concepts easier for you, but not at the cost of that you don't understand anything, okay? So there is a balance that I keep in my teaching style. So this is what I am keeping right now. But still, I want all the curious developers who are watching this video to go to the libuv documentation, right? Now, if you will go to the libuv documentation, right, over here, go to SRC folder. In the SRC folder, you will find that there are Unix and Windows, right? There are two folders, Unix and Windows. Go to any folder. Let me go to Unix folder. Over here, you will find core.c file. Core.c. This is the core C file, right? Of the event loop. Inside this file, you will find event loop. And what actually is event loop? What actually is event loop? Let me tell you, there is a function which is known as uv underscore run. Where is it? uv underscore run. There might be some function. See, this is the uv underscore run. This is the function where you will see the event loop, my dear friends. This is the function which is executing your event loop. We draw fancy diagrams, right? We draw these fancy diagrams and everything. These are just for our visual representation. This is how our human mind works. Our human mind works in form of images. When I show you such images, right? When I show you such images, the concept gets settled into your head. But I don't want to keep you far from reality. You should know in reality, event loop is not these diagrams or some time. There are no phases or something. At the end of the day, it is just some piece of code, my dear friend. It's just a C language code. See, core.c, this is C language code. What is event loop? This is event loop. And if you are curious, you can go and read the code of event loop. What it is doing? It is actually a loop. See this. This while loop that you see, is a event loop. Got it? People ask me, what is event loop? This is event loop, that is event loop, this is event loop. This while loop, at the end of the day, if you go to the code level, you will see that this event loop is the while loop. This is the knowledge I want all the Namaste Node.js students should have. Go read it up. If you are curious, go read the code. You will understand everything. If you will see the code also, see this is UV run. So now if you will see, let's start the event loop. See, the event loop starts. Now you will see the phases also. Okay, you will see the phases also. See, run timers. Do you see this? Initially, you are running the timers, right? You will see a timer phase. Okay, and you will see this while loop. So now you will see all these things, right? All these phases that you saw, right? You will see, this is the libuv diagram and this is the libuv code. This diagram exactly matches this code, right? If you will see this diagram, it will exactly matches this code. Let me just show it to you. Let me make it like this. And let me just take you over here. Okay, let me show it to you, right? Now let me just take some time and show it to you. I know, right? It is taking a lot of time, but let me just quickly show it to you. For the people who are interested, I just want to give them a little push, right? Because unless some people, some developers they are just afraid of reading documentation, reading code, but I want your fear to be gone, right? This is the uv underscore run. This is the uv run function. Just read this uv run function, okay? So what it is doing is initialize the loop time. So it is initializing the loop time, right? UV update time. Now it will run the due timers. So it is running the timers. It is updating the time and updating the timers. Now it starts the loop. Over here, it starts the loop. Over here, this loop is alive. So it will check for this condition. So I told you, right? It is a semi-infinite loop. It waits at the poll stage, isn't it? That is your homework. I will not tell you in the code where is that waiting thing, right? But it checks that, okay, it can sleep or not, right? It calculates whether the sleep or not. And when does it sleep? See, you got the answer already. When the UV queue is empty, right? The queues are empty, right? So that is when it can sleep, okay? Now, if it does not sleep, so it will call the pending callbacks. Do you see this? UV run pending, and then it passes in this loop, right? UV run pending. This is the function. If you can go to this function and you can also see this function is in this file. You can go and read the code of this UV run pending function also. I'm not showing it to you right away, right? Because otherwise it will take a lot of time to explain all these internal things. If you want me to make a video on it, maybe I will make some deep dive video on this on my YouTube channel or something. But I want to keep it light for all, because see, these videos are being watched by all level of people. Some people might want to go into it, some people might not want to go into it, but if you are curious, please go read about everything, because this code is huge, right? See how it is running the pending callback, right? So it is running these pending callbacks, right? Then see UV run idle, UV run prepare. So it is running the idle handles, it is running the prepare handles. Now what it will do, now it is calculating the timeout. See, I told you, right? Before it goes to the poll phase, it calculates, how to explain you, see, I'll tell you, let me try to tell you. See, libuv, suppose if you schedule a timer, so libuv knows that, okay, there is a timer which is ticking and it can expire, right? After, suppose if you ran a set timeout with 5 seconds. So libuv knows that, okay, 5 seconds, the timer will be there, and after 5 seconds the timer will expire. So libuv calculate the time that, okay, if there is nothing available in my all the callback queues, so for 5 seconds I have at least 5 seconds when I can wait in the IO poll queue. So now I know it can be a little complex, but let me see, if you don't listen to me very carefully, I can explain you that also, how it calculates. See, it goes to the timer phase. It knows that what all set timers are expiring, right? Suppose if there are 2 timers, one is 5 seconds, one is 10 seconds, okay? There is a timer for 5 seconds, there is a timer for 10 seconds. So it will see what is the latest timer, right? Basically, which timer, suppose if there are 3 timers, A, B, C. This is 5 seconds, this is 7 seconds, this is 10 seconds. So it will find out which is the timer which will expire the earliest, right? So timer A with 5 seconds will expire the earliest, right? So if all the callback queues are empty, and there is a timer of 5 seconds which will run after 5 seconds, so libuv internally calculates that, okay, in the poll phase I can wait for 5 seconds, right? Only after 5 seconds I need to go and run the timer. So basically libuv, before even going to the poll phase, calculates that how much time I have that I can stay in the poll and I can just keep polling events. Got it? Let me repeat it once again. So what libuv tries to do is, before going on to poll phase, as the poll phase is the most important phase, right? It just, because see, there are so many incoming requests that can come inside the poll phase, because poll phase is mostly used. So before going on to poll phase, it actually calculates that what is the timer, if there is some timer which I need to execute, right? And if it takes 5 seconds, then I can wait over here for 5 seconds. Suppose if there is 10 seconds for the timer to be left, so poll can wait here for 10 seconds, right? Once the 10 seconds are expired, then only it can go to timer and then come back to poll again. That is why it waits over here. So it calculates it, right? So I know I have not explained it thoroughly and in detail, but I would request you to please go read all of this, read the code. You will understand all whatever I am saying. Right? Now it goes to the IO poll, right? So it goes to the poll phase. Now see, again and run the check handle, close callback. See, if you will go over here, it runs the check handle, right? Then it runs the closing handles, right? Check phase over here. Over here, if you will go and see this, all the set immediate callbacks will run over here, right? In this check. Then closing handles, right? Closing handles, right? It will run the close handles. Then it will update the loop time, right? Update loop time. Then it will run any pending timers if there's there. And then the while loop will continue once again, right? And then it will check if the loop is alive or the loop is not alive, right? And then it will just run once again. So this is the while loop. This is the whole while loop which is running in, right? So this, my dear friends, is event loop at the end of the day. Hope you are enjoying this, right? So I want all my students to know this, right? Note down this path. If you can't find it, go to libuv. It is very easy, right? Go to source, go to Unix, go to core.c, right? You will find all of it. Try to read it, right? It will be amazing. Okay, so let's move ahead now. I wanted to explain you and show you all these things because these are very important. Event loop is the core fundamental part of the libuv, and libuv is the superhero, right? Libuv is the core part of Node.js. Without event loop, Node.js cannot exist. All the asynchronous task, all the non-blocking IO happens because of event loop. Okay, this is the major thing that you need to understand, and let's move ahead now. Now let's move to the thread pool. I told you that in libuv there is a thread pool. What is this thread pool? When libuv uses this thread pool is the question, and then we will answer the most famous question: is Node.js single-threaded or multi-threaded? Okay, so now you already know a concept that, okay, whenever there is an async task, so V8 engine offloads it to libuv. Basically, libuv handles that task, right? What kind of task can be there? Suppose there is a fs.any function, right? You are reading a file system, right? Suppose if you are making an API call, you are doing http.get, right? Or you are making a DNS call, or you are making a crypto, right? You are generating a password hash, and so many more functions are there. So many more utilities, modules are there, which are offloaded to libuv. Now, for some of these complex tasks, let me take an example. Okay, suppose if you want to read a file, you cannot read a file in this thread. Why? Otherwise, it will block our main thread, right? We cannot block our main thread. So what happens is, whenever there is a file read needs to happen, it offloads, VH Engine offloads it to libuv. Now what libuv does is, it finds a thread inside the thread pool. It has a thread pool, right? It gets a thread and it runs the file system, right? It runs the file access system using this thread pool. Understood or not, right? Let me explain you once again. See, libuv has a thread pool. Now, whenever you read a file, so libuv says, okay, libuv basically uses this thread pool to request the file. Got it? It cannot do manually. Similarly, libuv, see, suppose if you are doing any crypto, right? We saw a crypto function, right? Suppose if you are calculating, see, crypto functions are huge in itself, right? Basically, they are complex algorithm which needs to run. Suppose if you are encrypting a password, it takes a lot of efforts, right? So you cannot do that on the main thread. So we don't do this on the main thread. We don't want to block it. So we offload it to libuv, and libuv uses one of these thread pool to implement crypto. So what happens is, let me tell you, right? Let me tell you that, see, suppose if you are making an FS call, so it goes to the thread pool, and this thread pool basically makes this request to the OS, and then the file is read, and then the thread pool returns back, and the thread is available. Thread is then vacant. See, while the file is reading, this thread is completely occupied. It cannot do anything else. So, when this file reading is complete, so now the thread pool, like that thread which is like engaged, it just frees up. Then it is available for some other operation. Okay. Now, similarly, suppose if you are doing a crypto, right? You are hashing a password. So this crypto will again go check the thread pool, occupy a thread, and then runs it in the thread, right? Because see, what is a thread? Thread is basically, you can assume that, okay, it's a container where you can run some piece of code, and if you want to block the thread, block it. If you want to block that thread, block it, because if you block this thread, then it will not block our main thread, right? Our main thread will be safe. So it has a thread pool. The crypto happens over here. The file system call happens over here, it talks to the OS. Got it? So there are some functions for which libuv uses a thread pool. Because libuv will, how will libuv do, right? Suppose if there is a file system read which is coming up, so it takes a thread and it says that, okay, read the file. Suppose if there is one more file system call comes in, right? Suppose if there is one more file system call comes in. Now what happens? It will take another thread, it will occupy another thread, and this thread will make a file system call. Suppose if another file system thread came in, right? So it will take another thread, it will occupy another thread and will make a call to system, OS. Suppose, so now let me tell you one more thing. In Node.js, the size of the thread pool is 4 by default. 4 threads, right? This is known as UV threads, right? 4, right? The size is 4. Let me write it down properly, right? The UV thread pool, it is known as like this, right? Thread pool size is equals to 4. UV thread pool size is equal to 4 by default, right? There are 4 threads over here by default. So basically inside the libuv, there are 4 threads by default. Okay, suppose if there are 5 file reading calls I made simultaneously. Suppose if I make the 5 file reading calls simultaneously, what will happen? So see, let me just explain you with the help of diagram. See, one file call, it occupied one thread. Another file system call, it occupied second thread. Another file system call, it occupied this thread. Another file system call, it occupied the fourth thread. Now what happens? Another file system call comes in. Now it will have to wait for one of the thread to be empty. Right? It will not be handled immediately. So whenever there is an operation which needs a thread, so it takes a thread, does its job, and then frees up the thread, right? And then the next call can be can use that resource, right? Can use that thread, right? This is how libuv uses the thread pool. Okay. Otherwise there is no way that using just one thread you can do all of it, right? In the main thread we don't block it, right? All the asynchronous tasks are done by libuv using a thread pool, or sometimes not using a thread pool. I will come on to that later, but it uses a thread pool for a lot of things. Let me tell you an example. So when does libuv uses a thread pool? Whenever you do something like fs, you do fs.read file, right? So it uses a thread pool. If you do fs dot, there are more functions, right? So it in the fs module, it majorly always uses a thread pool. Okay, it goes to thread pool, and then thread pool will make a file call, gets back again. Got it? For DNS.lookup, see, there is a module which is known as DNS, right? So in DNS module, not for the other functions, but specifically for lookup function, right? This DNS.lookup, right? So basically